Morning, guys. Welcome to everyone. I appreciate everyone taking an hour out of their busy schedules to join us this morning. Most of you know who I am. If not, I'll probably get to meet you all in person at some stage, but I'm Manny from Sunlock, General Manager. Firstly, I'd like to say thank you for the opportunity, guys. We've got some special guests this morning. It's a pretty exciting webinar. We're going to keep it brief and obviously straight to the point. We've got limited time, so I'll be as quick as I can because usually I talk a fair bit, and I'll keep it pretty simple. So thank you to everyone. We've got some key speakers joining us this morning. We've got Nigel Morris, who's the industry veteran and the voice of the solar industry. Welcome, Nigel.
Thanks, Manny.
We've got both the key people here from Gamcorp. We've got Martin, who's the Managing Director and owner of Gamcorp, and we've also got Sana, the Project Coordination Manager, I should say. So thanks for joining us this morning, guys. This is our first official Sunlock webinar, so it's pretty exciting to have all three of you here. I'm going to sort of really touch on the reason why we're having this webinar, and it's quite important for us to let everyone know that we're trying to obviously inform everyone in the solar industry, specifically the commercial solar industry, that there's some big changes coming into play. We want to give you a really simple and easy explanation as to what these changes are, how they affect your business, how they affect commercial solar rooftop and design. And in saying that, obviously by using Sunlock products and Gamcorp, our engineers, you will achieve the best results for your commercial projects, which most of you already know. There is a long-standing relationship between Gamcorp and Sunlock, which I'd like to say thank you for the last 3 years, guys. And obviously you've helped Sunlock drive some significant change in the industry when it comes to commercial solar rooftop installations and driving best industry practice. I can probably officially say that we are the leaders in driving that space quite aggressively and getting everyone else to follow. So thank you. We're going to keep this as simple as possible, but there will be a lot of questions. There'll be some question time right at the end of the presentation, so all of you can send your questions through and we'll get to them all in a reasonable time frame. If not, there will be some communication and you can talk to us directly after the webinar. In saying that, this year we are at All Energy and Gamcorp will be at our stand for the full 2 days. So any other questions or follow-ups, you'll have the opportunity to meet and greet us all in person at All Energy this year. So thank you, guys. Thank you to Gamcorp for giving us that opportunity and for sharing the stand with us. And in saying that, I'd probably like to hand over to Nigel Morris, who has got some questions, but obviously he'll drive the webinar this morning. And over to you, Nigel.
Good on you, Manny, and g'day everyone. Great to be here. I have to say, actually, when I was listening to you talking about it, Manny, it struck me that one of the great reasons to be here talking today is because when you look at what's going on with solar around the world and especially in Australia, rooftops where it's at. All right, all the big volume and all the big generation in terms of how we're impacting on the grid is coming from rooftop solar, and the opportunities for commercial in particular are just enormous, and after a couple of rough years really starting to take off again. So I'm kind of here because I'm excited about rooftop. I'm here because over 30 years I've seen these types of rule changes that are going to be the focus of today's conversation really have some big impacts on people's businesses. So I'm really excited for everyone to come here and make sure that they're across this, because if you get this stuff right, you can actually use it to lead. You can actually use it to leverage some business advantage. If you get it wrong, you're putting a lot of risk into your business. And so it's really, really important. I haven't installed for a long, long time. So, I'm going to be taking the approach of being a dangerous idiot, a little bit of knowledge, lots of enthusiasm. So that's going to be my approach today. I am also on one of the Clean Energy Council product approval panels and have been a member of that for many, many years. So I'm really interested in learning more about the standards and some of the products that Sunlock have got and how Gamcorp are going to help everyone stay compliant. So that's why I'm here today. Enjoy the rest of the show.
Thank you, Nigel, and yeah, over to Martin.
Thank you, Manny. Yeah, we're very appreciative of being given the opportunity to be able to join with Sunlock in giving this update with regards to commercial solar installations. We've been putting out a lot of information since we first found out about the updates to the wind code a couple of years ago, and since it was released, those people on the webinar who are already customers of Gamcorp will have received a fair bit of information from us about this. A lot of it probably tend to be a little quite detailed. So hopefully today we're going to demystify it a bit, make it information that is more practical to installations and installers on a day-to-day basis, and probably help remove some of the confusion that might be around engineering certificates and also building compliance. So myself and Sana, who's our project coordination manager at Gamcorp, are going to go through the majority part of this webinar. I'm going to take the first part, which is the engineering certification overview, for about 10 minutes or so, just to set the scene and also to give you an idea about where rooftop solar fits within Australian building regulations as well, and some of the unknown requirements that people don't really know about, how this all fits in and the importance of having structural certification completed. And then Sana's going to take you through the major changes that are within the new version of the wind loading code that directly affect solar installations. There's actually quite a lot of changes that happened within the new version of the wind code that affects engineering and in general, but obviously we're just focusing on that is specific to commercial solar installations. So the first area of confusion that we sometimes see is what is the difference between a general certificate and a site-specific certificate? So these two terminologies or certificates come up a lot in conversation. And the proper name for the general certificate is really a PV array frame engineering certificate. That's the name that was given 10 odd years ago by the Clean Energy Council when we first started working with them in coming up with some standards that PV array frame manufacturers could work to say that they were compliant with Australian standards. And the important thing to know about the general certificate is that it's only a structural assessment of the array frame and the fixings itself. It's a one-size-fits-most. You'll see that terminology used by the Clean Energy Council now, which is a good thing, in that it uses a very broad set of design criteria to be able to determine whether or not it's suited. And when you see these, you would have seen them from many different manufacturers. They're usually 20, 30 pages long. They'll have lots of different tables. They'll mention things like wind region A, B, C, and D, and different terrain categories. And as an installer, you've got to then work out whether your site's in which wind region, what's the terrain category, what's the height of the building, and then determine what your spacing is going to be. But it's all based on assumptions because it's not taking into account anything to do with the site-specific conditions. There's no building assessment that takes place. So with regards to the fixings, if you're fixing into purlins, most general certificates will just take the most popular purlin thickness size, which is 1.9 millimeters. But there's a big variety of purlin thicknesses. They go from 1 mil to 3 mil, and the capacity of the purlin to be able to take that fixing is, as you can understand, varies quite greatly between 1 mil thickness and 3 mil thickness. They also will have different spans, and different spacings. Whereas a general certificate will just assume typically a 1.5 meter spacing of the purlins and doesn't take into account at all the span of the purlins. So whether they're spanning 6 meters between the rafters or whether they're spanning 11 meters between the rafters. And there's a big difference in how the roof is going to behave when you've got that sort of difference within here. General certificates, in our view, are a good guide to whether or not the array frame system is going to be suitable for the installation. So it's very much a preliminary check to make sure, do they have the right types of clamps that we need? Is it going to, what's the general spacing that we're going to be required with, or how far the rails are going to span? So it should only be used as a guide to see whether or not you should even consider that particular array framing certificate. With site-specific, so we hear the term site-specific. The term that we like to use, I suppose, from an engineering perspective is, and you'll see it on the title of our documents, is that it's a PV array frame installation certificate, because we're talking about the installation of an array on a particular site on a particular building. And there's a whole heap of other parameters that are now taken into account, not just the array frame. So this is when you start getting into specific roof pressure zones for that site. We'll be looking at the building structure. We'll be assessing whether or not there's going to be any long-term impacts to the building structure because of the additional loads that are being applied on. It's really, really important that you see this as a reference. So this is for a specific installation that's used as a reference to do the installation, and we're optimizing the installation parameters for the local site conditions. So we're taking all things into account: wind directionality, whether there's any shielding involved, and particularly we find with most of our assessments, it's the building that is typically providing the limiting factors on either how much can be installed or how far apart the feet can be on any one particular installation. It's very rarely that it's the array frame that limits the installation. It's usually the building that has the biggest impact. I think from an installer's point of view, with site-specific certification or the documentation that you get from that, is that it's much simpler to follow. So it clearly lists out, I suppose, the criteria that were used if someone else needs to check that. But from an installer's point of view, you've just got one table that specifies for the different roof zone areas how many rails you need to use, how many fixings, what are the spacings that they need to be at. So there's no need to be able to go through and be able to make any decisions about, well, is this terrain category 2 or is it terrain category 3? It's all specified. You don't even have to worry about that, because it's the engineer's responsibility to determine those sorts of things. So I think that's an important clarification I wanted to make between general certificate and site-specific certificate. The other thing that I wanted to raise with everybody was how roof-mounted PV panels are considered within the Australian building regulations. So, all states and territories, because every state and territory has their own set of building regulations, and there are certain areas that are slightly different. As you could imagine, in the Northern Territory, where you have cyclonic conditions, they have a whole set of different criteria than you might get in the Victorian building regulations. But all of them consider roof-mounted solar panels as an attachment to the building and not part of the building structure. So what that means is that they're in the same category as window shutters and awnings and things like that, in that, well, not so much awnings, but particularly window shutters, in that generally you don't need a building permit. So one of the things that really surprised me when we started getting involved in the solar industry a bit over 10 years ago was that there was nobody checking the buildings when the installations were taking place. Now, I can see how that happened, because at that time, the majority of the installations are on residential buildings. And we were talking small amounts of panels, 3 or 4 panels in a string placed in the middle of a roof. probably taking up maybe 20% of the total roof area. So in terms of the impact that it has on the structure, it was relatively light. But when you're talking about large warehouse type buildings that are built and designed as efficiently as possible, they want to use as minimum amount of steel, adding extra load into that roof is really going to have an impact. And where we're getting into the building regulations here is because there's no requirement to get a building permit, like as if you're going to put a veranda on the back of your house, you can't even start the construction until you have the permit. The onus here with any attachment to a building is to say you don't need a building permit as long as the installation doesn't affect the structural soundness of the building and it doesn't affect public safety. But how do you know that? You obviously don't know that unless you do the structural assessment. And the problem here is that, and there have been instances in the past where there have been either roof failures or you get the impact of excess deflection occurring in the roof, which may affect usability of the building. So we've seen some cases in the past in office buildings where installation goes on, everything's fine. Then on a windy day, when there's extra wind lift occurring, the purlins start moving up and down like 100, 150 millimeters. So they're not going to fail. They're within their tolerances in terms of ultimate strength. But these office buildings had suspended ceilings attached to the purlins. So every time there was a gust, the whole roof lifted up 100 millimeters and it dropped back down, and then the ceiling panels would fall out. So it's not going to cause the building to collapse, but it's pretty annoying if you're sitting at your desk and the ceiling panel above falls down on your desk. So those are things that are referred to as serviceability issues, but it still it's still considered part of structural soundness, serviceability, and things to do with deflection. Now, the key thing here is that local municipalities, so your local municipal building surveyor can take action against building owners that have completed building works that don't have a building permit. And it's ultimately the landowner's responsibility to ensure that any work they do in their building has a building permit associated with it if there's been an effective structural soundness or public safety. And so it's not the installer's responsibility, although they obviously could be taken civil action against them. But the important thing here is that it's the building owner needs to make that, ensure that doesn't happen on their site. That's within obviously taking action within the building regulations itself. The other thing I wanted to clear up, everybody know, it was just how the relationship between the main standards that are used within rooftop solar being 5033, which, as you all know, is pretty much the Bible with regards to solar installations. You need to follow everything. That's the overriding standard with regards to PV array installations. But how does that link in with 1170.2 being wind loading? And then also now, really for the first time this year, the National Construction Code has been brought into rooftop installations as well. So in terms of the relationships, AS/NZ 5033, as I said, is the overriding standard with regards to PV installations. And a small section of that, section 4, deals with mechanical things that we need to take in. And that's where there's a reference to 1170.2. And with the new version, with the 2021 version, there was a new requirement added in that pre-existing buildings must be checked for the additional loads imposed by the new system, which is new, which wasn't in there previously. So we need to then, because it says we need to make sure that there's no impact from the additional loads, that then references to 1170.2. So 1170.2 2001 was effective from July last year. So as structural engineers, we're pretty much obliged to use the most recent version of the standard as soon as it was already released and as soon as it supersedes the previous version, which happened in July last year. What happened, though, is that because we've got the National Construction Code, and because even though solar installations aren't considered part of a building and an attachment, there is a loose link to the National Construction Code, although there's no requirement to follow the National Construction Code specifically with rooftop solar installations. So what, in my opinion, happened in this instance is that because there were so many changes that are occurring within 1170.2 2021, a decision was made to tie the release of the National Construction Code with using which wind standard. Do we use the 2011 version or do we use the 2021 version? So National Construction Code 2022 was supposed to be released in May this year. It was pushed back due to all of the new energy efficiency requirements that are within this new code. It has quite an impact on new building design. And then, so it was now published it's on October the 1st. It is published, but all of the building and state, or the state and territory building ministers decided in a meeting back in August that they weren't going to make it effective until May next year. So that's, I suppose, the background towards the Clean Energy Council's media release that they did to members at the end of August, basically saying that up until the 1st of October, you can choose to use either 1170.2 2011 or the 2021 version, but you can't mix and match. From the 1st of October, their recommendation is that you should use the 2021 version of 1170.2. And then from May 2023, you must use it. So a bit of semantics there in terms of what they should be doing. What we're doing, how we're approaching this is that from the 1st of October through to the 1st of May next year, our default position will be to use the latest version of the wind code for all assessments. But if it is necessary, and some of the things that Lisanne will talk about, you'll see why, if an installation can't be optimized with the older version of the wind code, with the newer version of the wind code, we will default back to the old version to be able to help out customers if we need to. But we feel that we really should be using the new version of the code right now, and we have felt that way since July last year as well.
Martin, can I jump in with a question there?
Yeah, sure.
Just to give me the dumb version of this. There's a whole bunch of changes to the standards, but and solar installers know that they deal with standards all the time. If they've got their wits about them, they've got a bunch of standards that they have to be compliant with. And this strikes me as a typical standards conundrum,
yep,
where they've got multiple standards, new ones coming in, old ones going out, crossover periods, all that kind of stuff. At the end of the day, it's an installer's responsibility to understand the standards. But if I'm reading you right, one of the roles that you guys play in conjunction with Sunlock is actually being the guide, I guess, is advising people how to make sure they're compliant, because yes, at the end of the day, it's very, very tricky. I mean, there's a bowling club down the road from me that had a rooftop install that actually caused the roof to collapse not that long ago in a big storm. That destroyed the bowling lanes, which, as you can imagine, are fairly expensive. For a typical solar business, that's going to kill you, right? That's going to cripple you. So yep, am I right that the role that you guys can play is to actually help navigate all of this?
Exactly. Yes. Yeah.
Right.
That's right. And I think, as I say, with this relationship between the two things that are important for solar installers is really just 5033 and 1170.2. They're the two criteria. introducing the National Construction Code at this point has really just confused everybody, because there is no need to reference it, because it's to do with the construction of buildings. It's not to do with the construction of attachments to buildings. So it's just this weak link that's been tied in to be able to delay the implementation of it. It's the main thing. If some point down the track, I'm sure it will happen, if we look at what happens in the United States, for example, at the moment, where about 40 odd out of the 50 states require permitting on every solar installation that's done. So it's then part of their building standards and their construction code. That will happen in Australia eventually. It's probably 3 to 5 years off in my estimates, but there will be a point where there will be required to be permitting, which obviously there's electrical permitting, but from a structural point of view, there will be permitting required for solar installations. You know, it's something as significant as a solar installation on a large warehouse. It just doesn't make sense to me that it's not considered part of the structure. You know, it's something that's just missed out, and our building regulations haven't caught up yet.
I'll jump in again there, because I mean, for any installers who missed it, WorkSafe New South Wales were on Facebook this morning warning installers they've got a snap inspection regime going on around New South Wales over the next month or so. And we know that with the clean energy regulators focus on behaviour and standards compliance and everything else at a federal level, there's a really enhanced focus on this. Martin, and what you're sort of forecasting is, I guess, a trend that we've seen coming, that, compliance and enforcement against these standards is getting tougher and tougher and tougher. Is that what you're saying? Yes. Yeah, that's right. I mean, you can see just with the declarations that need to be made by installers and designers now from the clean energy regulator. I mean, that's that first step, and when you're making that declaration, with regards to compliance to 5033, you're making a declaration that you have checked the building roof, because it states it in the standard. So finally, I just want to finish off just with regards to the relationship between Sunlock and Gamcorp. As Manny mentioned at the start, we've been working together for a long time. And it really was a risk that Manny and the team at Sunlock took on, offering site-specific certification for all of their installations. No one else was doing it. And it was a bit of a education process that they had to take on as well in convincing their customers that this was required as well. So, I really appreciated the limb that they went out on in really supporting us to be able to get our message across as well. And in doing that, all of Sunlock's customers, when they're making an order for a commercial installation, are offered the ability to be able to have this done at either no cost or as a subsidised cost. So there's two options at the moment that Sunlock offers customers can choose, and it's done online. Option A is the site-specific array frame certificate. So this is just the array frame. It covers roof pressure zones, it covers rail overhang, fixing spacings, rail orientation and things, but doesn't include a check of the building. Why we do that is that because a number of Sunlock's customers are either working with other engineers or the building owners themselves have their own engineers that will do the check on the building itself. That type of assessment is of no cost to Sunlock customers. And typically, if someone was to come to us directly for that, it has a value of around about $1,100. Option B includes the array frame certificate as well as the building structural roof assessment as well. So this is the whole solar array installation engineering certificate. We're looking at all parameters, including the building, the site, the array frame, the panel size, everything, to make sure that everything is covered before the installation takes place. And Sunlock provides a 50% cost recovery on that for all of their customers. And for a typical installation, that was normally about $2,050 worth of value.
All right, that's all I want to cover. It probably took a little bit longer than we were prepared to at the start, but I'll hand it over to Sana now, who's going to go through some of the details, cut out the engineering jargon, and hopefully give you some information that will help you planning your next installation.
Awesome. Thank you very much, Martin. Very important information. And to be honest, it's probably something I receive phone calls at least once a day about, what permit and what do we do now and what's happening next. So I really appreciate the time to clarify all that. It has taken a bit of time, so I'm going to have to rush through this a little bit, but the real purpose of my conversation here today is to cut the jargon, right? Engineers, we love to talk in details and talk about formulas. And although that is very important to us, it's not so important to you guys, right? So let's look at the main three things that are affecting the solar industry that we've identified in the last year or so. But more than anything, it's going to be something that we have to keep our eyes on and keep peeled on how it's going to change moving forward, because we haven't felt the full effects yet, because we haven't done every type of installation with the new code. From the stuff that we have seen, the biggest impact we're finding is with the fixing assessments. And I want to talk a bit about what we do here in the assessment so you understand the effects it has when I talk about the changes. So usually when a building's initially designed, it's designed for something called a uniformly distributed load, as if to say the wind is going to hit this roof really nice and evenly. And now we have, 2 square meters of panels, if not more, and they're being held by a couple of legs on a couple of rails. Right, that now means that the pressure has changed from the way the building was designed, from this nice and uniform load over the roof to a couple of point loads that are acting at different areas on the roof. Now, we can argue that, with flush, it's similar pressures and whatever else, and with tilt, there's only a slight increase in pressure. But the way the building has been designed initially is different to the way we have to assess it now to make it compliant. And that's going to be the real tone of everything I'm going to talk about now. Is we're looking at existing buildings that were designed by a previous code or a previous time, and now we're trying to assess it with the current code and the current time, and we're really starting to see some red flags and some nasty points. So let's run through them now. The first one is roof pressure zone. I think 5 years ago when we started doing this, solar installers would swear us for putting a map where there was particular zones with higher wind pressure than others, which meant more rails and clamps. And now it's become quite an industry, expected and almost accepted thing, right? So the roof pressure zones has had some big impacts, and they've just chucked a nice little ×2 in front of the end of the formula. In the previous code, these pressure zones are obviously calculated by the building dimension. So depending on how high and how wide your building is, it has a factor that calculates these A values and these edge zones. Now, this new code has put a nice 2 times in front of the end of the formula on very typical warehouse style buildings. Now, I'm saying typical warehouse, it ranges with this kind of rectangular, low-rise warehouse when it's probably 5 to 12 meter range, and that kind of wide and long kind of structure. With these types of buildings, what used to be a formula that would end with the zones being equal to the height of the building, in this case 10 meters, that same building now, if we're looking at the exact same building but applying it to the new code, you can see that the zone is now 2 times that of what it was in the old code. Now, nothing's really happened. The building designer hasn't done anything wrong. He's designed it for a period of time with the code at a particular A value, and now they're asking us to double that A value. Now, for all new buildings, that's fine, because we can, with the building designer, we'll design for this level of pressure, and then when you're trying to put solar on it, it can be designed for the pressure that it's going to be assessed to. But when we're looking at old buildings that used to have, my faces are covered here, but it used to have 7,000 square meters of internal area, and now it's been reduced to only 3,700. That really now is 50% of the roof that we were used to be able to use that we can no longer use. So it's a issue for us as engineers to now look at a building and apply these new zones and tell people, mate, more than 50% of your building isn't working. It's not to say that it's not working. I don't want you to run back to the customer and say your building's going to collapse. It's far from that, but it is important to say that what was initially designed for compared to what we have to check it now is creating this level of difference. So to break it down, the biggest red flag we've seen on the industry today is the changes of these zones. So to make it very, very clear, and I say this, I want to really take this opportunity to tell the 100+ people that are here today, that this is going to happen more and more as the kick in next May comes into full effect. But effectively, this is what this is what the original engineer has designed for. These loads on the underside of this image, these dashed lines is what we have to assess it to. Now, the biggest problem with this is that this green zone now is effectively a yellow zone. That yellow zone usually has about a 50% higher pressure than this green zone. Now I'm checking this green zone with 50% higher pressure, and it's just not working. I can try and add rails and I can try and add clamps, but the building's deflection itself, when we're checking the building, it's not working. So the biggest problem we're going to have is that we're going to be really seeing a lot more of this internal zone that has had little change in comparison to the edge zones. More of these areas being installed, but less of these larger corner zones and these larger edge zones. The building was not designed to take them type of loads. Bit of a red flag.
Santa, can
Yes.
I ask a question here?
Please.
Just let me get this clear. So I understand the building regulations have changed. So the way that a building is looked at is changing with these new
Correct.
standards that we've been talking about. But this is going to affect existing buildings, not just new buildings, right?
I would say it's really majorly affecting existing buildings and less affecting new buildings, because when a new building is being designed,
It's built to the code.
engineers will design to that code, right? They'll design
okay.
to the current code.
Right. So the
And
biggest implication for solar installers is you know, if they get asked to throw solar on a building that's 10, 15, 20 years old, that's been designed under the old codes, they can't assume that old building is going to be assessed from a structural point of view under the new codes now. So effectively what this means is that to manage your risk as an installer, you're going to have to be thinking in terms of the new codes, even though it's an old building. Is that right?
Correct. And not just that,
Right.
if there was something to go wrong, and then God forbid that ever happens, but if there was, whoever was to check what conditions you've met to will check it against the new code and say you've done something incorrect, even though
Right.
you and me and that client might know the building's built, perfectly when it was built.
Yep.
The legality around it is not around anyone's opinion, but what we have to actually certify to and check to today.
Right.
And
So
that's
for insurance claims, for your own public liability insurance, you're going to be booted out. The insurance assessor is going to say, "No, mate, you weren't compliant." Simple as that.
Absolutely.
Right,
So that's become a big issue. Moving on, there's a lot of other changes, and I really don't want to spend too much time talking about every single one. It's really good for engineers to know, but not so much for solar installers to know. So I really want to break through and just talk about other key changes that are going to really affect us both. I know we have some New Zealand people here as well, so let's go through and do both now Australian, New Zealand wind region changes. Again, you might have heard already that there are some changes to the wind region. Obviously, some are positive, some are negative, but in saying that, there is some really big red flags again. And it really is me pointing out to this particular zone in Brisbane. It also has been affected other areas as well, but to give it a really good and clear example of why this has been a big problem for this area of Brisbane, I'll get to the next slide, which kind of explains this particular segment. Now, this region, this Toowoomba region, in the previous code, the pressures that had to be allowed for was for a different wind region. Now, this Toowoomba region falls under this new region B1. Now, this region B1 has approximately about a 46% increase in wind pressure. Now, what that means is, on top of the fact that what we talked about just before, that these pressures in the roof are already increasing, now you have a building that's in Toowoomba that was designed to a previous code, well approved, and nothing wrong with the design for its time. And now you're asking any engineer to assess that building, and you're telling them to assess it to the current code. Now that building has to do that same amount of, it has to account for that same amount of wind, with the exact same structure, has to account for 46% extra wind. And then people argue about why it's failing, right? And it's impossible for us to do, justice to the original design engineer, because although they may have done a great job, it's stacked against them, right? You've got an extra 46% of wind on a very simple structure that was suitable for its time. So really, the deathly combination, which we'll get to, is when there's a typical building with increased wind pressure zones in this like Toowoomba new wind affected region, and it becomes an impossible task. So we'll get onto that in the next slide. New Zealand have also got their own zoning now, which has had increases across the board, ranging from about 6 kilometers an hour to about 22 kilometers an hour. More than ever before. And in fairness, New Zealand have been a lot better in regards to having structured compliance and doing the steps and checks to make sure that everyone's covered, including the building owners. So it's less of a concern to promote this because they're already doing well better than what we are doing in Australia. But in saying that, now more than ever, the increase of wind means the same kind of issue. Buildings would be designed for a certain wind. It's got an increase of wind. Site specific is more critical than ever before. And now moving to the site exposure multipliers, there is a bunch of them. I think the couple that need to be, have some particular highlight mentions. The first one is the terrain category 1.5 has been removed. And the second one, the biggest one for us that we've seen actually affecting our actual assessments is the shielding multiplier being removed for buildings with greater than 25 meter height. This is a conversation I love having with installers. I have it at least once a week where they say, I've got a building, but next to it, there's another building that's a bit higher, and next to it, I've got another building that's a bit higher, and that kind of blocks the wind and whatever else. And it is true to a certain extent. Now the code has made it not true in any extent. If a building is greater than 25 meters high, which is a lot of buildings these days, 10 stories, gets there, we cannot allow for any form of shielding. So we have to take the full force of the wind according to its condition. So it's a bit of a negative for us. Obviously increases that wind pressure on that building. And again, that building may have initially been designed with them considerations with wind tunnel testing and whatever else to get a lesser wind due to the shielding. Now we can't rely on that when we're doing assessments on existing buildings. The change to the site exposure, again, this applies to New Zealand guys, is the changes to the leaf factor. If you aren't aware, the leaf factor is effectively the effects of wind due to mountain or like higher terrains versus lower terrains, like topographical situations. There was a lot of concern with the previous code where you could assess two areas very close together. One had a variable of 1 and another one had a variable of 1.35, and they're just 100 meters apart. It made no real sense. They put a lot more clarity on that and made it a lot more specific and accurate. Again, this changes the way buildings were designed, depending on what leaf factor they use. If now the clarity has created an increase of pressure, then it's going to likely affect a lot of your assessments. Again, site specific, very critical in these particular situations as well. Other points I'll touch on, and I guess the reason I put this slide here is to tell you there are positives. Sorry, there are a lot of negatives. We focused on them, but there are some positives as well, right? And positives, I think all of this is a positive because really until we catch up, until new buildings are designed to this level, it's going to be a lot better for the industry, a lot better for the buildings and so on and so forth, right? We're catching up against other countries and against other standards. But in saying that, at the same time, there is, red flags for us right now compared to what we used to and the way we've been doing things for as long as we have. In regards to wind direction multipliers, there's been a reduction of about 11% in certain conditions in certain wind regions. We've seen some wind speeds in Region C and Region D are no longer constant, which gives us a potential reduction of about 13%, which is another positive change for the industry. There's positives and negatives. The positive, for example, is the fact that they've added this climate change multiple. Give me 1 second. Sorry, the climate change multiplier is not a positive. It increases it by about 10% in regions B, 2, C, and D, but this uncertainty factor for cyclonic regions was removed, and that would previously increase it by 5 or 10%. So it's kind of like a positive and negative there, where there is some increase in variables in one set, but they've made some clarity and put some clarity on the other things that we can remove and not take effect on as well. So in general, I just really want to skim over this. I know the formulas don't make much sense to most of us, including myself at times. So it's really important that we just touch on it so everyone knows. But I really want to make this the main point of this presentation. And I really want you to think about this, reflect on this, reflect about the businesses that are into them, that are doing installations, reflect about what this means for a lot of people that are trying to use these areas to perform assessments. When you increase the wind by 46% because of a newly adopted wind region, and then you double the size of corner and edge zones and internal zone, half the size of internal zone, you're really affecting the commercial output in these particular areas. And even if it's not in this particular area, even just doing this on a large building that hasn't been designed for it, I can assure you there's never been a builder who's, just in case the wind code changes, doubled the strength of their roof structure, right? It's a huge cost to builders. So they're really skimming this down and cutting the cost of roof areas down. And now solar installers, bless you all, are like, I want to use 100% of the roof, right? And we would love to be able to do that for you every single time, but our hands are becoming more and more tied, and these are more and more challenges that we're kind of facing, especially with this new wind code update. Martin explained this very well, the CEC and the effects of it into the new code. So I'm going to just skip the slide if that's okay. Now, the truth, I really belittled the hard work of the standards in the engineering industry in Australia by just really skimming through this and making some touch points. For the people who have come here that may have wanted a more technical review, I really appreciate your time so far, but I would recommend you listening to one of the best in the industry in Australia, John Holmes, has done a YouTube video from GHG changes, and that really goes into a lot more detail, really nice summary of all the changes, very high level technical review. If you are interested in that level, please, I recommend you watch it. I watch it a couple of times myself. In regards to more technical stage from us, we do run a more technical presentation as well, more suitable for engineers. But again, if anyone has that experience, has that drive or want to know about it in more detail in regards to the formula changes, please let me know. And then lastly, an offer that I really want to propose to everyone, and obviously it's free for all Sunlock customers as well, is a solar PM training. And we do this at no cost for organizations. Put a couple of your guys together. If you can set an hour aside, we really teach you what are the considerations that we take when we're doing an assessment. What are the red flags you look into when you're walking into a project and you're trying to quote it or trying to figure it out. And at the same time, it gives you more clarity when we have conversations around why this is the case or why this isn't the case. You'll be like, oh yeah, reference to that presentation. That bald guy from Gamcorp said this and this and this, and you'll be better for it. So if anyone wants that as well, feel free to reach out to us, and we're happy to help you with that as well. Guys, I'm going to hand it back over to Manny.
Over to me. So I think, Nigel, there's a couple of questions that have come through.
Sure is, Manny. I'm going to pull those up now, and then we'll get the answers. That's great. Thanks for all the questions, everyone that have come through. First one has come through, and I think maybe this is a good one for Martin. In financial terms, is there any motivation for installers or clients to go with the new standards without holding off until May 2023? I can think of one straight away, and that's about risk minimization for your solar business, perhaps. But how else would you respond to that one, Martin?
Yeah, I think risk is probably the biggest factor. I think when it comes down to it, we'll always recommend that you should use the most current version of the standard, because the standard committees don't make up these things just to annoy everybody. That's based on research and things that's taken place. The other thing to keep in mind is that at this point in time, where you've got this crossover period between the versions, which in reality only happens about every 10 years. So it's not something that happens, every 2 years, is that if there's a building certifier or a building surveyor that's involved in the project, and some of these larger projects, particularly when they're large property owners, like owners of like industrial estates or shopping centres and things, they'll typically have a building certifier or a building surveyor involved. They're the ones who have ultimate responsibility or the decision with regards to which standard needs to be applied. So we've had a number of cases come through our office where we've done an assessment according to the older version of the code, and this could have been in like the second half of last year, and we didn't know that there was a building certifier involved in the project. It was, and in a lot of cases, the solar installer doesn't know that until the information goes through to the building owner, and their engineer or their reviewer then says, why are you using this version of the code? The latest version of the wind code was released in July 2021. And then we have to redo the whole thing again. So one of the important probably questions that an installer should ask the building owner, particularly with large commercial installations, is is there a building surveyor? They're referred to as building surveyors in like Victoria and Queensland and in South Australia, but they usually referred to as building certifiers in New South Wales and Western Australia, because they're the ones who we can make an engineering judgment and say this is what we should do, but when it comes down to building compliance sign off, that's the building certifier or the building surveyor's responsibility.
Can I add as well, and not to cut you off there, man, but there's a really important other point here, right? And we've identified some red flags today. We've talked about some big concerns of the industry, and they should be aware of it because these conversations are going to happen more often than not. But there's also positives as well. And when we do assessments side by side, old code versus new code in this transition period, we found some sites with benefits, right? Reductions in rails and strength in certain building conditions and stuff as well. So it's not all bad. And I think it should your approach should always be go with a new code that's current, up to date, in case there are third parties, in case this comes back, in case the building owner requests it. And if it's a significant negative, leave that to us. We'll call you. We'll have that conversation with you and say, hey, this is the situation. There is an element that we have this grace period to use the old code. Is there something you want to adopt in this particular case to improve the results and so on and so forth? So that's always a conversation that can be had, but it really should always, the focus should be try and get the best result with the new code.
I love it. Great answers to the question, guys. Thanks. And we've got a lot of questions to get through, so I'm going to get you to squeeze your responses down just a fraction if I can. That's okay. That's okay. I'm going to throw one in here, and there's a couple of questions that have come in that are kind of relating to this, but I'm going to throw this one to Manny. So, I mean, if I'm not mistaken, Manny, you know, one of the things that Sunlock's worked really, really hard on is, you know, creating a mounting structure that minimizes the risks and you know, leverages everything you can from a structural point of view, but also you guys are bundling in the services of Gamcorp into what you supply to the market, right?
Absolutely. Good question. Look, anytime you ask me a question, you know, about Sunlock's products, I'm always going to say they're the best because I believe they are. And obviously we put a lot of time and effort and engineering into our design and products to get them out to the market. In my opinion, and I think a lot of people agree with me, there's a lot of Sunlock users out there. The results tend to be better when using Sunlock. A lot more is achievable on a rooftop. The type of aluminium we use in our products is a higher grade than a lot of other people, a lot of other suppliers. The product's quite unique. It's built for commercial application. That's what we do all day, every day. You bundle the best product that's engineered to withstand the highest wind loads, and I suppose in a commercial environment, to the point where, you know, we've got cyclonic testing on our product, hands down one of the strongest products on the market. You bundle that with what we're offering to our customers, which is, you know, the engineering services, where we don't leave room for error on every single project. Every single project is looked at on its own merit. Every building's different. Your purlins, you know, every building has different purlin thicknesses, different spans. So what I'd like to say that we're quite proud of, and I've worked pretty hard for, with, I suppose, within Sunlock and with the industry and with installers, is to deliver the best possible outcome, taking into considerations all factors of a commercial rooftop. So in saying that, yeah, we do deliver the best possible outcome when you're using Sunlock products on any commercial rooftop. You will get a better outcome and maximise, I suppose, the amount of solar you're trying to fit on a roof compared to any other product on the market, and that's a fact. Obviously, with the support of Gamcorp, and we're not pushing the boundaries in any way, shape, or form, but we're taking things to the absolute line of best practice. And, you know, installers love our product. They get it. There's a lot, you know, that I can keep talking to you about how good Sunlock is, but I think the general consensus is everyone knows how good we are, and because we're so thorough and diligent with every single commercial job.
Thanks, Manny. Another one of those great short answers. I'm gonna slap all of you when I see you for your long answers, right? So keep them short because we're really running out of time. What I am going to say extremely quickly is, having gone back a few years, the ability to buy a product that I know is engineered to the nth degree and get engineering services all as one service is just a wonderful thing. So good on you guys for doing that. Really good one. I'm going to throw this one at you, Martin. You've got 15 seconds to answer this. It's about point load, which is a really good question. This has come up in my past where you go, can I put 4 80-kilo people standing on one spot in a roof? You know, do the new standards affect that? You've got 30 seconds at most to answer a point load question. Do the new standards change this?
No, I mean, in terms of how you deal with point loads, no, it doesn't. So Santa mentioned it before. I mean, the main thing to consider here is when the buildings are designed and the roof is designed to accommodate for wind pressure, the worst wind pressure is suction, usually as the wind passes over the building, and all of the roof sheeting is pulled up all at the same time across the roof. You know, and as Santa mentioned before, now we're changing it. The pressure that's acting on the surface of the panels hasn't changed when they're flush mounted. But now instead of the whole roof, we've got all of that pressure from the panel transferred down to 4 or more points that are either fixed to clamps on the roof sheeting or down onto the purlin. So where that purlin previously had an even pressure along its entire span, it might, for example, depending on the layout of it, now have all of that pressure in one point in the middle of the purlin instead. You know, so
Gotcha.
all of that force is now is all on one point. And that's where serviceability comes in. So serviceability deals with deflection of structural elements. Where it was this long 15 seconds before, but where the wind pressure might have been before when it was uniform distributed load might have been about 15 millimeters deflection. You change that to a point load where you got all of that pressure on there, your deflection might change to 100 millimeters.
Got it. All right. There's a bunch of really good questions that have come through, but unfortunately we are really out of time. But the good news is I know Manny and Pepper are going to follow up. So anyone who has sent a question that we didn't get to today, don't worry. We will come back to you. We will get the answers to you. I'm going to throw to Manny to close off for the day.
Yep, sure. So this has actually been quite overwhelming. There's so many people that have attended this webinar this morning. There's some good questions. If we haven't gotten back to you, we'll get back to you. The presentation will be sent out to all the attendees as well. By all means, you know, at any time, feel free to call myself, Sana or Martin. We're all accessible and available to take any questions. And again, Gamcorp will be with Sunlock at the Sunlock stand at the Expo if you want to meet us in person, have a chat. Otherwise, yeah, email, phone call. Really appreciate everyone's time today. Thank you, Nigel. Thank you, Martin and Sana. Always a pleasure. And yeah, thank you for everyone's time. I think that's just wraps it up.
Appreciate your time. Thank you, guys.